Alright, this is the Algebra 2 Rationals Review Part 2. Number 13 says algebraically solve for x. First thing I see is a minus sign. I hate subtraction, so should you. We're going to distribute that minus sign to the numerator. Now in order to solve this, we need a common denominator. And in order to get one of those, we need to factor everything, all the denominators first, which x plus 1 can't be factored, so we'll put it in parentheses. Now, I have a 2 and a 4, and together they make 8, but 4 is actually smaller, better one to use, but if you did choose an 8, it would still work. I have an x on the outside, which means I need an x on the outside, and I also need this parenthesis. So the smallest common denominator you can use is a 4x with an x plus 1. Like I said, if you used 8x with an x plus 1, you should still get the right answer. Alright, we need to make every fraction have that common denominator, so we have to multiply by what's missing. So the first fraction needs a 2 to turn that into a 4, and then it also needs the x plus 1. So I'm going to multiply that to the numerator and denominator. Second fraction needs the 4x on the outside, numerator, denominator, and the last one needs the x with the x plus 1. Alright, first fraction, this 7 and this 2 get multiplied to be 14, and that 14 is going to get distributed inside. So I have 14x plus 14 over my common denominator. Negative 2 times 4x is negative 8x over my common denominator. And if I distribute my 1x, I get x squared plus x over my common denominator. And now that my denominators are all the same, I can drop them. And that leaves me with the equation. I'm going to combine like terms while I'm at it. So that'll give me a 6x plus 14 equals an x squared plus x. Problems like this are a lot of work, so the people who make them are going to make sure that this is factorable, which I find faster than quadratic formula, so I'm going to set this equal to 0, which if you're using quadratic formula, you'd still have to set it equal to 0. Okay, you can do quadratic formula if you want, but I'm going to factor. The two numbers that multiply to negative 14 and add to negative 5 are negative 7 and a positive 2. Set each one equal to 0. X equals 7 and x equals negative 2. Now, anytime you solve an equation that has fractions in it, you need to make sure that your answers do not cause undefined fractions. So if I plug a 7 into my original denominators, will I get a 0? No, so 7's fine. If I plug a negative 2 into either one of these denominators, do I get a 0? No, so that makes both of these answers good answers. Number 14 is one of those problems that I should not have put on there. My apologies. This is a division problem. You don't know how to factor the numerator. So we're going to take the backdoor approach, which says plug in your favorite number greater than 2. So I'm going to plug in a 3. So everywhere I see an x, I'm going to put a 3. And I am going to type the numerator into my calculator. So 2 times 3 to the 4th plus 8 times 3 cubed minus 25 times 3 squared minus 6 times 3 plus 14. And I get 149 divided by 9. And I get 16.5 repeating. So now I want to figure out which answer choice will give me 16.5 repeating. And I can cut down on the amount of work that I have to do here, because if you look at number 4, there's no fractions in number 4, and the only way I'm going to get a repeating decimal is if I have some sort of fraction involved. So it can't be number 4, and it can't be number 2, because also it does not have a fraction involved, so there's no way I can get a repeating decimal if I'm not dividing by anything. Alright, so for the sake of the only one that has some room, I'm going to check number 3 first. 2 times 3 cubed minus 4 times 3 squared minus 3 plus 14. Let's see, 3 plus 6 is 9, so I'm just going to leave that. So I'll get some sort of decimal. 2 times 3 cubed minus 4 times 3 squared minus 3 is, this is equal to 15. And then 14 divided by 9 is 1.5 repeating, which gives me the 16.5 repeating. So it's lucky that we started with number 3. All right, number 5. Which expressions are equivalent to x squared minus 4x all over 2x? All right, so again, this is equivalent expressions, so that backdoor approach will always work. And actually, on this problem, I would suggest that you use that to check your answers. Because again, this is some tricky fraction work here. If I were to simplify that fraction, I would take out a GCF of an x, and that would give me x minus 4 all over 2x. And then from here, these outside x's will cancel, which gives me x minus 4 all over 2. So I know the second fraction for sure is equivalent. But the rest of them are fancy fraction work. Now I'm going to take a look at number 3, and right away I see that number 3 has common denominators. So if they have a common denominator, I can go ahead and subtract them. Well, I hate subtraction, so I'm going to distribute the negative up here. And when I combine like terms, I get x minus 4 over 2, which is the exact same thing as choice number 2. So far I got choice 2 and choice 3 that I know work. What about this choice number 1? It was kind of like that fancy footwork that we did on one of those other problems in the first video. But I see a 2 here, which means something got divided and left me with an answer of 2. But if I take a look at this, x squared minus 4x all over 2x, I could separate that into 2 fractions. And that would give me x squared over 2x plus a negative 4x over 2x, right? So I'm separating them into the addition problem they were at first. And now I can simplify each fraction on their own. So right here, one of those x's is going to cancel, so that'll leave me with a single x in the numerator over 2. And here the x's will cancel, and negative 4 divided by 2 happens to be negative 2. And when we look at it that way, choice number 1 also works. So for number 15, the answer is 4. All 3 of them are equivalent expressions. Again, this is one where the backdoor approach probably would be easier. Just plug in that 3 and see which ones come out to be the same values. Number 16. Again, they're looking for equivalent expressions, so you could take the backdoor, plug in a number, and figure it out. But I'm looking at all the answer choices, and I don't see any of those weirdo fractions added on to the end of any of those answers. So I'm thinking this is a straight out factoring problem. And we do know how to factor the top, so I'm going to say let's do it by factoring, because that's the math we wanted you to learn anyway. Factor by grouping, because it's a 4-termed polynomial. GCF is x squared. GCF of this group is a negative 9, because your group starts with a negative. So when I get done factoring, I get x plus 2 and an x squared minus 9, except I notice x squared minus 9 is difference of squares, so I'm going to factor it again. X plus 3, x minus 3. Now I have a trinomial up here. First kind of factoring is always look for GCF. Well, I can take an x out of all of them. And now what multiplies to a negative 6 and adds to a negative 1? That would be a negative 3 and a positive 2. Alright, so now we got to put our fractions together. We have x plus 2, x plus 3, x minus 3 in the numerator. We have an x minus 3, and an x plus 2 in the denominator. cancel out like terms. There goes the x plus, or sorry, the x minus 3's, and here go the x plus 2's, and that leaves me with an x plus 3 over x, making choice 3 our answer. All right, number 17. What is the solution set to the equation? Okay, if they give you an equation and possible answers, technically speaking, all you need to do is plug those answers in and see if they work. But honestly, that's about as much work as doing the problem straight anyway. So we're going to go ahead and do the math that we learned, which is you need a common denominator. In order to get your common denominator, you try to factor all the denominators first. X stays the same. We package up the x plus 3 because we can't factor it. So we got those. Our common denominator will be the x that's not in parentheses, because he's different from the x that's in parentheses. So our common denominator is x plus 3. I'll now need to make everybody have that common denominator. First fraction gets multiplied by x plus 3 over x plus 3. Second fraction is x over x, and so is the third. Distribute the 2, so we get 2x plus 6 over our common denominator. Then we get 3x squared. Uh-oh, is that a minus sign that I forgot to distribute? Yes, it was. All right. Sorry, guys, that was a subtraction problem. I totally blew it. Change it to addition. Distribute your negative. So that makes it negative 3x squared over x plus 3. And that makes it an x squared over x plus 3. Okay, so I didn't realize that was a minus, or I totally forgot to finish that thought. Okay, so denominators are the same, drop them. And we have a negative 3x squared, positive 2x, positive 6 equals x squared. I know this should be factoring because these are nice pretty answers anyway. Factoring is easier when your squared term's positive, so I'm going to move everything to the right side of the equation. So that gives me 0 equals 4x squared minus 2x minus 6, which I can divide everybody by a 2. Okay, this dividing by 2 is not a required step. It just makes the numbers smaller. Whatever I do to one side of the equation, I do to the other. So I still have it equal to 0, but now I'm going to have to do some factor by grouping. Front times back is negative 6. Negative 3 times 2 will add up to the negative 1 in the middle. So fill those in. Hopefully this factoring stuff is old hat for you. GCF of x, GCF of a positive 1. So I get x plus 1 and 2x minus 3 equals 0. Set each one equal to 0. So x equals negative 1 and x equals a positive 3 halves, which is choice number 4, but remember, anytime you deal with fractions in an equation, check to make sure you don't get an undefined. If I plug a negative 1 into either one of my denominators, I don't get a 0, so that's okay. If I plug a 1.5 into each one of those x's, I don't get a 0, so both answers are good, meaning number 4 is the answer. Okay, 18. Again, we have another equation. So I hate subtraction, so do you. Distribute that up to the 3. Try to factor all your denominators. X plus 3 can't be factored. 4 minus x, it can't be factored, but that's backwards. We're used to seeing it as x minus 4. Well, I know that there's a negative 1 trick that I can cancel opposite orders if I put the negative 1. Well, I can do the same thing if I want to change the order. So if I want to change that to an x minus 4, I need to do it with the negative 1 trick. Mathematicians will put the negative 1 in the numerator so it doesn't get lost. So if I put a negative 1 up in this numerator, but there's already a negative 3 there. If I multiply them together, that's going to change it to a positive 3, and then I can call this an x minus 4, which I want to do because when I factor the next one, I get x minus 4, x plus 3. My common denominator will be much smaller if I use an x minus 4 instead of the 4 minus x. So that's a trick you're going to want to be able to do. Common denominator is just both parentheses. So first one gets multiplied by the x minus 4. Second fraction gets multiplied by the x plus 3 over x plus 3. Last fraction is the same. So distribute the 2. I get 2x minus 8 over the common denominator. Then I distribute the positive 3 now and get 3x plus 9 over the CD. And the last one stays the same. Denominators are the same, cross them off. So combined like terms, we get 5x plus 1 equals 2x minus 2. Subtract 2x from both sides, and we get 3x plus 1 is negative 2. And we end up with x equaling negative 1. But because we just solved a rational equation, we need to make sure that this does not cause a 0 in the denominator. So if I plug a negative 1 into the first denominator, I don't get a 0. If I plug it into the second denominator, I don't get a 0. So my answer is, in fact, negative 1. All right, 19, another solving equation. So I hate subtraction, so do you. Factor denominators means wrap that in parentheses, pull out a GCF. Common denominator is the x with the x minus 2. Multiply the first fraction by x over x, the second one by x minus 2. Last fraction stays the same. So we get 2x squared over the common denominator. And distribute your negative 11, so negative 11x plus 22 all over the common denominator. And equals 8. Drop your denominators and set it equal to 0. Again, you could use quadratic formula if you want, but because of all the work, they're going to be factorable. But we have to do grouping. So 2 times 14 is 28. 4 and 7 will add up to 11, so I have to make them both negative to make the negative 11 in the middle. Groups 2. GCF, the first group is 2x. Second group is negative 7. Set them equal to 0. So one answer is 2 and the other one is 7/2. And again, we need to go back and check. If I fill in a 2 to my first denominator, 2 minus 2 equals 0, which means it's an extraneous solution. I don't want to count it. If I plug in a 7/2 to x minus 2, I'm fine, and if I plug it in for x, I'm fine. So 2 is the extraneous solution. That's the extra one that doesn't really work. So choice number 1. All right, and number 20, to finally wrap it up, this is another one that I should not have put on there. This is the division problem, and it has some really weird looking answers. So we're going to do this with the backdoor approach. My favorite number is 3. Again, you want to pick any number that's above 2. 3 cubed plus 2 times 3 squared. And let's see, in the numerator we get negative 40. In the denominator we get 45. So negative 40 divided by 45 is negative 0.8 repeating. So our goal is to find somebody that equals negative 0.8 repeating. Alright, well, your guess is as good as mine. We might as well just start with choice number 1. Negative 3 times 3 minus 3 divided by 3 squared plus 2 times 3. Let's see, that's going to be a negative 12 in the numerator. 9 plus 6 is 15, and I believe that comes out to be a nice rational decimal. Sure does, negative 0.8, but not 0.8 repeating. So this is, whoops, didn't want the repeat bar. It's just negative 0.8. It does not repeat. Number 1 is not our answer. Number 2, negative 3 times 3 minus 1 over 3 squared. So that gives us negative 10 divided by 9. Negative 10 divided by 9 is negative 1.1 repeating. So that's not our answer. Negative 3 times 3 to the negative 1 plus 1. Ooh, negative 3 times 3 caret negative 1 plus 1. Comes out to be 0, so that's not our answer. We're hoping it's number 4. Negative 3 times 3 to the negative 1 plus 3 to the negative 2. Negative 3 times 3 to the negative 1 plus 3 caret negative 2. Hey, and we get negative 0.8 repeating. So number 4 is our answer, and that is the end of the rationals.